Good morning, class 9 students. Today we are going to discuss about the chapter 2 polynomials. So as you have already discussed many concepts about this chapter, as we are going to do it again. So the first concept is constants. A symbol having a fixed numerical value is known as the constant. For example, 2, 3, 4, 5. And the next one is related to the constant, that is variable. The symbol which has assigned a different numerical values, that is known as variable. For example, x, y, z, a, b, c and so on, that is known as a variable. The next concept is algebraic expression. The expression containing both the constants and the variable with the mathematical operations like addition and subtraction is known as algebraic expression. For example, 5x or 2x minus 3, x square plus 1, etc. That is known as algebraic expressions. You have already done this in the 8th class. Then is the polynomials, the expression which contain more than one or more than one term, two term, three term with a non-zero coefficient. Non-zero coefficient means the coefficient should not be non-zero. It should not be zero, because if zero is there, the term will become zero. So that type of expression is known as the polynomial. A polynomial can have any number of terms. You have discussed this in your lower classes, that if one term is there monomial, two terms are there binomial, three terms are there trinomial, and three or more than three terms, then it is known as polynomials. That is below in this worksheet also. You will just go through and you will see. Now polynomial in one variable. The expression, the polynomial, the algebraic expression when it contain only one type of variable, whether it is x or it is y, it's a, it's b, it's c. So that type of expression, entire expression is known as polynomial in one variable. For example, a square plus 2a plus 5 is known as one variable. Then now you take the same example, that a square plus 2a plus 5. So now you know that a square plus 2a plus 5 has now three terms. We have done this. So a square is one term, 2a is the next term, and 5 is the another term. So the term, what is now term? Term is either a single number, for example, that is only 5 or 2x, or it can be a combination of term, as in the example a square plus 2a plus 5. So that is always separated with two operations, that is plus and minus, not with multiply and division. Now coefficient, the number multiplied to the variable is known as coefficient. As we were discussing in the above expression, that a square plus 2a plus 5. So in the term 2a, so in the term of 2a, the 2 is the coefficient of this term. So the number is 2 with that variable. That number with the variable is known as the coefficient. Now if we take the example of 2x, then the number 2 is become the coefficient of the term. Next is constant polynomial. So when a expression consists only constant is known as constant polynomial. For example, 7, 2, 3, minus 6 and so on. Then comes zero polynomial. Zero polynomial, the constant polynomial 0 is known as zero polynomial. Means it should not be any other number. Only the number 0 is known as the zero polynomial. Then we can denote the polynomials in one variable. Now if we are saying that the variable in a polynomial is x, then we can denote the polynomial as px. And if the variable in the polynomial is y, then we will denote the polynomial in py. Similarly, py, qx. Generally we denote the polynomial either px or qx, or if variable is y, to py or qy, right? Now comes, as we have already discussed at the top, I have discussed that types of polynomial may monomial one term, binomial two terms, trinomial three terms, or three or more than three terms is known as monomial. That's nothing new for you. And expression may terms always divided by or separated by plus and minus sign. Then here comes the degree of the polynomial. The highest power of the variable in a polynomial is called the degree of the polynomial. For example, the expression given or the polynomial given below is x5 minus x cube plus 7 is, now what is the degree? Highest degree is 5. So the power of all the expression Three terms are there, na? X5, degree is 5. X cube, degree is 3. 7, degree is 0 because it's a constant. So the maximum or the bigger number is 5. So the degree will be 5. So the degree of non-constant polynomial is always 0, right? The constant does not contain any variable. So if there is no variable, the degree of that term will be always 0, right? Don't forget this. Then comes the another way of dividing or the types of polynomial. Here we say that linear polynomial, quadratic polynomial, or the cubic polynomial. Linear polynomial, the variable degree should be 1. Quadratic, the variable degree should be 2. And the cubic polynomial, the variable degree will be 3. I will give you examples. For example, in the linear polynomial 2x minus 7, as you have done in class 8, we have done the linear equations and all. Na? So that is 2x minus 7. So x is having power 1. So that's known as linear. Now when this x will become 2, then it becomes quadratic polynomial. See in the next in quadratic polynomial example, x square minus 9. When the power of x become 3, then it becomes cubic polynomial. For example, x cube. Now see in cubic, x cube minus 9x plus 2. So that becomes a cubic polynomial. So x power is 1, then it is linear. Power is 2, then it becomes quadratic. And power becomes 3, then it will become cubic polynomial. Then after that, it comes how to write a polynomial in a journal form. That is always written as an x raised to power n plus an minus 1 x raised to power n minus 1 plus so on we carry on with the last term a 0. Now zeros of the polynomial. Zeros of the polynomial means we have to find the values of the polynomial. If we take one expression or polynomial, that is x plus 2. So we have to put this polynomial equals to 0. So x plus 2 equals to 0. The 2 is plus on left hand side. When it goes to now right hand side, it will become minus 2. So x value will become minus 2. That value of variable is known as the zero of the polynomial. So now some important points are there. That is, a non-zero constant polynomial has no zero. Second one, a linear polynomial has only one and only one zero. And a zero of a polynomial may not be zero, or zero might be a zero of the polynomial. Please try to understand this one. That is, zero of polynomial might not be 0. Every time it is not necessary that answer will come 0. And 0 cannot become the 0 of the polynomial. So it's not necessary. A polynomial can have more than one 0. Now we will do some examples related to this. Find the value of the polynomial. So we will find the value of the polynomial. The polynomial is 3a square plus 5a plus 1. At a is equals to 3. Now the value of a is equals to 3. So we will put the value of a in our polynomial 3a square. So a square we will put 3 raised to power square plus 5a. So 5 into 3 plus 1. Then we will simplify. See in the third step. 3 multiplied by 3a square plus 5 multiplied by 3 plus 1. When we simplify, it becomes 27 plus 15 plus 1 is equals to 43. Similarly, in another next example, we have put x is equals to minus 1 by 7 in the px 7x plus 1. So 7, x value is minus 1 by 7. 7 is in the denominator, 7 is the numerator, it will get cancelled. It becomes minus 1 plus 1, that is 0. So see, I have told you one important point. Now 0, it's not necessary that 0 is the answer or not the answer. That we have discussed. Now here it comes. Similarly, you can check out the third example yourself. Now comes to remainder theorem. That is very important theorem in this chapter. So remainder theorem is nothing special. In the lower classes we have done a division. So division may we do dividend is equals to divisor into quotient plus remainder. That is the only thing we are going to do in the remainder theorem. Nothing special, but we will now write in a symbolic form. But now in the theorem, the statement is very important. So the statement is let Px be any polynomial of degree greater than or equal to 1, and let a be any real number. If px is divided by the linear polynomial x minus a, then the remainder is pa. So here now we have px polynomial with a degree greater than or equal to 1, and px, that means polynomial, is divided by x minus a. So the quotient will be qx and remainder will be rx. So in general form it can be written as px is equals to x minus a into qx plus r. It is the same form as we have done in lower classes. Px is dividend, x minus a is the divider, qx is the quotient plus rx is the remainder. Now we will do the proof. So degree of x minus a is 1 and the degree of rx will be less than the degree of x minus a. So rx degree will be 0. That means rx should be constant, not variable. You know, when we divide the polynomials, as in 8th class we have done division question, when we divide, the remainder should be always in a constant form. It should not be in any variable form. That is the wrong division. You all know that. Now from the 5th step we will do the proof that now when we put x minus a is equals to 0, then x value will come a, just see in 4th step. And now x value a we will put in a polynomial. So p a, then a minus a q a plus r. When we will solve a minus a, it will become 0. So hence 0 into q a will be 0 plus r. So hence its answer will come r. So therefore hence it is the proof of the theorem. Now we will do some examples related to remainder theorem. First type of question is divide the polynomial 3x square plus x minus 1 by x plus 1. This we have already discussed in class 8, division of the polynomial. So x plus 1 divided by 3x minus 2. So when we perform the division, the polynomial 3x square plus x minus 1 with the x plus 1. So we divide it. So x, what we need now, 3x. So 3x multiplied by x plus 1 will become 3x square plus 3x. Now you see that we have changed the sign and 3x square minus 3x becomes 0. So x minus 3x is minus 2x minus 1. Hence we simplify and at last we will get the answer 1. So we can rewrite in the general form bx is equals to qx into x minus a plus rx. So same way we have written, dividend was 3x square plus x minus 1. Then comes here divisor, that is x plus 1. And then comes the quotient 3x minus 2 plus remainder 1. Now there is more examples. Cubic polynomial we have divided in the next example. Please try it yourself. And then comes the next theorem, that is factor theorem. Factor theorem mein, if px is a polynomial of degree n greater than equal to 1 and a is any real number, then x minus a is a factor of px if pa is 0. And now reverse the statement. Above statement you just reversed in the second step. If pa is equals to 0 if x minus a is a factor of px. See, both the statements are the vice versa of this. Means one thing is important for the other. So similarly the other is also important for the first. If xa is minus factor of px, then pa is 0. And if pa is 0, then x minus a is the factor of px. There comes the factor theorem. You have to only memorize this statement only up to this. Now comes the example related to that. You can see by the factor theorem, we have to put the value only. Now what is the polynomial? X cube plus x square plus x plus 1. It is what is the factor? X plus 1 is the factor. So at factor you have to put equals to 0. X plus 1 equals to 0. X value is equals to minus 1. Now in px we will put x value minus 1. So p minus 1 equals to 0. When we put minus 1 in the value of x everywhere, our answer comes 0. If answer comes 0, then x plus 1 is a factor, otherwise not. This is the first type of question. Now the second type of question is find the unknown value of variable k in the question, when already we have told you that x minus 1 is a factor of the px. Now you see your px in the next example that k unknown variable is given, x k square, x square minus 3x plus k. So as the factor theorem here, p1 is equals to 0. So k minus 1 square minus 3 into 1 plus k is equals to 0. Third one step में what we done, k minus 3 plus k is equals to 0. K and k becomes 2k minus 3. 3 goes that side, it becomes 2k equals to 3 and k value become 3 by 2. So two different types of question. One may you have to prove that one polynomial is the factor of another polynomial, and in the second one we have to find the unknown value of k. Then the third one is factorization. Factorization, you know that this is important question, very important question for 3 marks. The factorize 2y cube plus y square minus 2y minus 1. So first step is that trial and error method. We will guess the value, and by guessing means you have to put the value of variable and the equation answer should come equals to 0, and that will become the factor. For example, in the above example given here, 2y cube plus y square minus 2y minus 1 we have to put. Now here I have taken the value of y equals to 1. So p1 and 2 1 raised to power cube plus 1 square minus 2 minus 1. When we'll simplify, answer comes 0. So therefore 1 is a factor of this polynomial. So y equals to 1. But 1 when goes to the left hand side, it becomes y minus 1. Hence, y minus 1 is a factor of the polynomial. Remember this. What number fits, its sign will change when it will go with the variable. If here is minus 1 factor, then it will go and become y plus 1. But in this example here it is y minus 1. Now we will divide our polynomial y minus 1 with y minus 1. So when you divide, as you can see here, 2y cube plus y square minus 2y minus 1, we divide by y minus 1. It is 2y square you divide, and then it becomes 2y cube minus 2y square. Change the sign. Then we will get first term get cancelled, and second term में y square plus 2y square become 3y square. And then we will bring other two terms down, minus 2y minus 1. Again, what do we need now? 3y square multiply by y, we will get. So what do we need now? 3y. So 3y multiply by y, it becomes 3y square. Again 3y multiply by minus 1, it becomes minus 3y. Change the signs. So we simplify. First term get cancelled. Second way, minus 2y plus 3y becomes y. And the last term comes down, minus 1. Then we have to multiply by 1. It becomes y minus 1. Change the sign and it becomes 0. Now we get another equation, quadratic now. We have discussed at the starting, 2y square plus 3y plus 1. It's a quadratic equation. Now that quadratic equation, we have to split the middle term. You have all have done in class 8. So when we split the middle term, 2y square plus 3y plus 1. Just see in the fifth step we have done. First factor is y minus 1. Second is 2y square plus 3y plus 1. Now we have to split. We cannot keep it in quadratic. When we split the middle term, 2y square, 3y factor is 2y and y. We have done 2y common, y plus 1 plus 1 common, y plus 1. Hence the three factors, first one is y minus 1, then y plus 1, and then 2y plus 1. Please try this question. I know it's going to be a little bit difficult for you, but please practice this. Now the last one comes your identities. You all have discussed your identities. First 4 identities we have already done. A plus b whole square, a minus b whole square, a square minus b square, and x plus a into x minus b. So that you have already discussed and revised it thoroughly. Then comes the next identity, fifth one, a plus b plus c whole square. Now as you have done the 2 terms whole square, the same 3 terms. So first term square, second term square, third term square, plus 2 into first into second term, plus 2 into second term into third term, plus 2 into third term into second term. So now in detail I will tell you, a plus b plus c whole square is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Similarly, we have done the question here example. Just go through as we will scroll down. See now, we have done to the question 4a square plus 16b square plus 64c square plus 16ab plus 64b square plus 32ca. We can do this and use this identity both in expansion and factorization, but here the example is of factorization. So 2a square becomes the whole square of 2a ka whole square. 16b square becomes the whole square of 4b ka whole square. Then 64 becomes 8c ka whole square. So here now see in second way, 2a whole square plus 4b plus 8c. Now in the next three terms are 2ab, 2bc, 2ca. So first term is 2a, second term is 4b, then 2 into second term 4b, third term 8c, then 2 8c third term, and then first term 2a. So hence it is the whole square of 2a plus 4b plus 8c ka whole square. Then we have more identities, that is cubic identities, that is a plus b whole cube and a minus b whole cube. It is similar to each other as we have done in square terms, expansion of square. Then now in the cubic, a ka whole cube plus b whole cube plus 3ab into a plus b. Next, a cube minus b cube minus 3ab into a minus b. Just the difference is there that in square we have done 2ab. But here with 3ab we have to put a plus b also. Remember this. And in minus identity we have put all the sign minus. And a minus b whole cube can also be written as a cube minus 3a square b plus 3ab square minus b cube. We have done nothing. We have just opened the bracket 3ab into a minus b. Okay. Then the last identity is a cube plus b cube plus c cube minus 3abc. This is left hand side, and right hand side will become a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So now the first example you can see it's with the fourth identity x plus a x plus b wali. And the 102 into 107 example is also with the same identity. We can write 102 as 100 plus 2 and 107 we can write 100 plus 7. You have done in class 8 these all examples. Please try to do it again in your rough copy. Then this next third example we have done. Now cubic identity we have done this x minus 2 by 3 y ka whole cube. So first term ka whole cube, that is x cube. Second term ka whole cube, 2 by 3 ka whole cube, that is 8 by 27 whole cube. Then minus 3ab into a minus b. Please solve and simplify and we will get that answer. Then come the factorization with the 8th identity, last one. 8a cube plus 27b cube plus 64c cube minus 72abc. It is used with the 8th identity. 8a cube can be written as 2a ka whole cube, 27b cube is written as 3b ka whole cube, and 64c cube can be written as 4c ka whole cube, and 72ab abc is written as 3 into first term into second term into third term. This is the left hand side. What will be the right hand side? Remember the identity? It was a plus b plus c. So that means first term plus second term plus third term. That is 2a plus 3b plus 4c. Then in the second bracket we have first term ka whole square plus second term ka whole square plus third term ka whole square minus ab minus bc minus ca. So we have done the same way. 2a ka whole square plus 3b ka whole square plus 4c whole square minus 2a into 3b minus 3b into 4c minus 4c into 2a and so on. So please try to solve all this. I know it's not going to be easy for you to do it out, but please try to make it out. Take out your copy pen, practice it out. I've given you this worksheet. I've given you the solved list. Please try to solve and we will discuss all the questions. If you have any doubts, do all the examples done in that and do all the questions given to you till last and learn all the definitions. Try to make your some sort of notebook or your rough notes for that, and God bless you. Thank you very much.